The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, good morning, wherever you are in the country. It's Mark from SolidCAM. We'll be doing our 30-minute free training session for SolidCAM Live. With me is Kevin Rankel. Hey, Kevin.
Hey, how's it going?
Not bad. Hope everybody's okay. So I thought today we would continue with kind of the same idea we were talking about yesterday, where the geometry can help you better program your parts, can help you to achieve what you're looking for. Today we'll cover something that's actually been covered in two separate tips and tricks videos on the YouTube channel, split line and untrim of a surface. And if you haven't seen those videos, we're going to pretty much review those real quick in today's 30-minute session. Let's start with the split line. Now, this is a function that you can get from SolidWorks that actually allows you to split a surface, or at least split a face on a solid, to make it a little easier for programming. For example, let's just take a look at this surface right here. So what I've basically done with this one is I've created this edge right here along these surfaces and split them right on that edge. And the reason I would do that is because if you look at the original edge over here, those surfaces are continuous. If I were to try and do any kind of HSS on this, I would pretty much have to choose a strategy of HSS that allows me to go a little further down this way, allow for changes in angles and such. But with this one, what I did was I just did a constant Z in HSS, and I get that nice, clean tool path. And I did that by just basically limiting the travel of the tool by the geometry, not from any of those other options we talked about late last week, where we're doing limit by number of cuts or by 2 points. Here, it's the geometry that's driving everything. So how do we do a split line? So let's take a look at that. So let's go back to our original guy over here.
I'm just happy
now,
you said constant Z instead of constant Z.
You know, I've been, ever since I started with this company, I've been doing Z instead of Z, and it interrupts my personal life sometimes. They think I'm an American now because I keep saying that. So. And it's on my license plate too. So every time I have to tell someone my license plate, they always think I'm having like a stroke or something. I'm like stopping short of saying Z. Okay, so split line allows you to split a surface from some sort of interface. And the interface that I find the easiest to use is if I go into design model, I like to add a plane. Because a plane is a little easier than if you were to try and draw a sketch or something like that, because oftentimes you know that you want to split this on a particular plane or like a Z level, Z level. And for instance, on this one, I probably want to just stop short of that edge right there or this plane right here, because that would give me the ability to do my constant Z toolpath. So I'm going to create a plane using the plane function inside of SolidWorks. That's pretty much just this plane right here. I'm going to tell it that it is a distance of 0 from that plane. So I'm basically just recreating that surface as an entire plane. And the thing with planes inside SolidWorks is they are infinite. This is just defining a plane in Z, in the SolidWorks Z, that goes on forever. So when I find the intersection of these faces with that plane, I don't even need to really worry where that plane is. I can just basically choose a plane anywhere that I want to do a sketch, and then it'll just find the intersection of all those faces with that plane. So that's just making the plane. But the actual split line, the thing that's going to give me the separation of the surfaces that I'm looking for, is under curves, split line. There's 3 ways to do the split line. You can project the surface. You can project a sketch. You can do intersections of different sketches and such. That's how I created that E in that previous video we did with the cross hatching of the surface toolpath. If you remember that from last week. So you can do that with sketches. Here I'm going to do it with the plane, because like I said, the plane is infinite. So it makes it a little easier to just say I'd like to do one just slice across the surfaces with my plane, and then I'll choose the surfaces that I want to split. So I'll just choose this guy, and this guy. And you can see it gives me a little bit of a preview, that yellow line, of where it's actually going to split. Now, split line doesn't destroy or eliminate or delete any surfaces. What it does is just literally splits them. So those surfaces are still there. They still represent the faces of the solid. But by splitting them, now I can actually give my HSS toolpaths or my HSN toolpaths or anything that's going to rely purely on the geometry for limits of travel. I can now just choose that one surface and then get it to go right to that edge there. So let's exit out of the part and let's see how that works. Let's just open this guy up. and we'll do a save and copy. And because it's constant Z, I don't have to do anything other than just choose my surfaces. So I'll just choose all my new surfaces over here. And you can see that with the split line, now it understands I just want to go to that point. I've got it set to my option there of staying within the edges of the surface. I'll just save and calculate. And we can see that we get that nice, smooth toolpath like that. And you can use split line not just in this one direction as a planer, but you could actually get it to just split any direction, any edge that you like to make the geometry a little simpler. This is more for surfacing, but some of the HSS, HSM, HSR, 3D machining, anything that you want to just kind of limit the travel of the tool using the surface, split line is a real easy way to get edges. It's not even the kind of thing you can really say, oh, it really applies to this sort of toolpath. You never know when you're going to need to modify a surface to get it to be a little cleaner for use. But I found that this one is pretty useful when I'm doing anything to do with surfaces where I just kind of want to give it a little more of a definition of where the tool is supposed to go or what surface I'm trying to machine. Actually, I used this yesterday when I was doing a 4th axis part for a customer, where to do the outside edge of a part on the rotary, since it's one continuous surface, the OD of a part, there really are no edges for you to select in terms of where you'd like to do your wrapped pocketing geometry. Again, something we've covered previously. To get those edges, I use split line. So as soon as I split that surface, now I have edges I can use for my wrapped pocket geometry. Any questions on that?
Not seeing anything coming through.
Okay. So it's not that hard to use. It's really just the intersection of whatever plane or sketch you use with your surfaces. If you ever have any trouble with this, you can always give us a call and we can help you with that. Or you could take a look at the YouTube channel, and I made a tips and trick video specifically on just this one function. That's how useful I think it is. Now, let's take a look at another surface-based function called Untrimmed Surface. Now, the functionality of this one, you can see on this part, it looks a little more like it'd be helpful on the 5-axis side of things. And the way I described it in the video is basically like this. If you take a look at any of these surfaces, they're pretty clean-looking surfaces, but when you try and use them for, let's say, this 4th-axis toolpath, you get this kind of disjointed toolpath here where it kind of stops in short of certain areas and stuff. It's not the cleanest-looking one. But if I were to use the surface that you can see here that has those square edges, now I have nice continuous lines for my blend between boundary curves. I can actually extend it outwards for things like lead in, lead out. If we take a look at my modified toolpath, I get these nice smooth lines go all the way across. So how do we get that actual surface? Well, outside of actually going and doing surfacing inside SolidWorks, which is always a possibility, especially for 5-axis. You can do your lofted curves, your sweep curves. You can try trimming. You can even use a split line here if you wanted to. If you saw that this kind of, let's get a more representative edge here. So if this thing here, if you wanted to just kind of do a split line to get that nice cross section so you can get that edge, that'll help you as well. But let's say we don't want to do any of that stuff. We're just interested in getting this nice original surface here. Well, what you would do is, you can see I've done it twice on this part. Let's do it again on this surface right here. Is again, you go to your feature manager, right click on design model. So now that we're inside the design model, we have access to things like the faces of the solid and that sort of thing. We'll go to the surfaces tab, knit surface. Now usually knit surface is the SolidWorks function to collect a bunch of surfaces and knit them together so they become one surface. So when you go and select things like any other surface function inside SolidWorks, or on our side of things, when you do HSS and you've got a bunch of different disjointed surfaces and you want to collect them in one selection. Let's say you want to do a really simple gouge check selection, or if you're doing HSS, HSM, HSR, and you want to just do a one-click definition or something like that. You can use knit surface to collect all those and make those one thing. Or another good example of knit surface is when you bring in a like an IGES file or a SEP file of just surfaces. It's more specifically maybe like an IGES file where it's just surface-based geometry, and those enclose a volume, and you want to turn that into a solid. This function also does that as well. You can see there's one here that says create solid. So if you actually have a fully watertight set of surfaces, you can make a volume, make a solid out of that, and that can help you sometimes later as well. But what I'm going to do here is I'm just going to choose the single surface. And basically what happens here, when I click the green check mark, I'm knitting one surface to itself, but you can see it actually just makes one surface. So it's almost like I'm copying the face from the solid and making it as a surface. Now that's important because all these other functions up here are related to just surfaces, not necessarily the face of a solid. So when I want to use the untrimmed surface function, I can only do it to surfaces. I can't do it to an actual face of a solid. If I click on that, it doesn't like that it's a face. But if I click on my surface that I created, now it untrims it. Now, untrim is usually the opposite of the trim function, where you actually gave it a sketch or a plane and you're trying to trim it, very similar to what we saw with the split line, where split line, it'll just divide it down the middle and then you keep the two pieces. Whereas trim surface will actually allow you to choose which of the two sides of that trimming, in this case a plane, you get to keep. And then if you don't like it or you want to untrim it to make a different trim, you can do that. That's what the untrim is. It's basically the opposite of the trim surface. Since we're using it here, essentially what we're doing is we're telling it that same idea. We want it to untrim for whatever changes were made to it. The change made to it in this case is that it's a face from a solid and it's trying to trim it to this face of the solid here. So when we say untrim, we're basically telling it to continue the tangency, continue that surface there. So you can see there that it's making those sharp edges there. Hopefully that's coming through. When I click the green check mark, it creates that surface. It actually is that surface that we knitted before, now untrimmed. It's almost like I just did an extension of those edges there. So rather than going through and making any kind of three-dimensional sketches and trying to loft or anything like that to copy this face, I just took the same face, copied it, untrimmed it, and now I have a nice clean face that has sharp edges on it that I can use for my 5-axis toolpath. So again, not that complex, but well, on this part anyway, but this can be very helpful when you're doing a 5-axis part, especially like this one. When the customer showed me this part and they weren't sure exactly how to do their 5-axis, or in this case, 4th-axis toolpath, it can get really complex because if you're trying to do morph between boundary curves, or you're trying to do some sort of parallel to curve or something like that, and then you've got this oddly shaped trimmed surface here, trimmed edge, you're doing a lot of retractions, you're doing a lot of trimming of the toolpath, whereas if we do this nice sharp corner here, we've got nice smooth splines we can use, and in this case, it actually gives us a little bit of a better connection between the passes, because if you remember, with 5-axis and HSS, essentially what you have is slices, and if the distances between the slices are large enough, it will retract to the clearance plane. If you get something like this, the distances are not that much, and you get a nice smoothness between the slices. So not only is this making it a little easier to program, but it makes the toolpath a lot smoother as well. Kind of like that. Now I got this one to go back to the clearance plane only because this is they wanted a really good finish on this. So this is a one-way cut. So it just keeps retracting and doing a one-way. So any questions on that?
Blowing them out of the water.
Yep. Like I said, these look like they're very easy examples. This is not always easy, for one, but it can really help with the programming side of things, because a lot of times we like to show toolpaths, the power of the recognition of the toolpath, or how easy it is to program the toolpath. But sometimes the ease of that toolpath is helped by the geometry side. So between yesterday and today, that's kind of what I wanted to show. That a lot of the SolidWorks functionality, because of the integration, we can use that. A lot of people skip over the functionality of SolidWorks because they just need to get programming. But you'll find that sometimes when you put the work on the design side, it really helps on the programming side. But if you don't know how to do surfacing inside SolidWorks, or even how to get it, you want to right-click on any one of these tabs, and then you can go to tabs, and then you can see the tabs available to you. Now, in this case, we're in assembly mode. If I go back into the solid, obviously we get different tabs. And if I right-click here under tabs, we see a lot more. So to turn on the surfaces, just check the box there. But that also might require your surfaces to be part of your SolidWorks license. So if you don't have surfaces, you can always check with your reseller. If we are your reseller, then you can check with your sales guy. And then once you get the surface-based functionality, you can do a lot of good geometry for your 5-axis, for your 3-axis work. There are some times where I would add a surface for gouge checking. A surface that isn't even part of the part, but if I make a surface that happens to represent just a wall that I don't want it to pass, and rather than doing any of those limit by number of cuts or limit by 2 points or anything like that in HSS, if I draw an additional surface and just say that's my check surface, then I can trim the toolpath a little easier than if I went and tried to manipulate link between slices, limit by number of points, any of those kinds of changes or modifications. Let's see, so let's hide the wireframe and see if I can show you basically what I was talking about. So if we were to do, let's say, a split line, just trying to think how we can get a cross section of that. Let's do something like this. Go features, plane. And if you remember, basically at the beginning of this video, or at the beginning of this class, I used the plane for the intersection to get that cross section. I'm going to do the same thing here. Now, it might split the surface, but what I'm actually going to do is I want to just grab that edge, and then we can do a sweep of that edge, just to show you guys how sometimes you can just create surfaces as well. So I'm going to do a plane that is perpendicular to that spline. And then I'm just going to tell it that it actually passes through this point right here, and that locks it in place. So if you haven't done planes inside SolidWorks, it goes all the way back to your geometry, your algebra, I guess, maybe from grade school, elementary school, high school, whatever you guys call it. Whenever you guys start doing planes, you know that it's either 3 points, 2 lines, a line and a point, or in this case, the way SolidWorks operates, you just need any kind of reference where it's going to lock this thing in the space. So if I tell it to be perpendicular to that spline, but at that point, it can only exist here. And I know I'm done when it says fully defined. Okay, and then all I'm doing here is on this plane, let's do a sketch. And then instead of converting entities, I'll do a intersection curve. So this will give me that same preview, or at least it should. There it is, okay. Didn't give me a preview, but it's doing what I want it to do. So in this plane, if I do an intersection with that surface, I get that cross section right there. And that cross section is going to allow me to do a sweep of this curve. So exit out of that sketch. Let's go to surfaces. Very similar to the solid extrusions kind of things that you do inside SolidWorks, you get the same functionality inside the surfacing. In this case, I'll go to swept surface. That's asking me for my cross section, which is that sketch that I just created, and then my path. I'll just grab, let's say, this guy like that. And in that case, I can do something very similar to what we did a second ago, but it doesn't actually extend all the way. So that's kind of the limitation there. So I would, if I want to do it like this, I would have to add some more sketches. I might go and maybe make a 3D sketch from that point going outwards, extend that a little further. If it doesn't line up exactly, which in this case, luckily it is, I have all these abilities here to do twists and stuff like that. So when it comes to surfacing, even though this is SolidWorks, there's still the surface capability. It's very limited, but it can give you what you're looking for. So there are some times where I do this with a 5-axis toolpath. I will create a cleaner surface to help with the 5-axis toolpath. If you're trying to do anything with surfaces and it's a translated part, sometimes those translated surfaces are not good. Sometimes they don't translate well. There's a lot of noise there. And because of the way the surface-based toolpaths operate, they will pick up on that. And you'll get toolpaths that go in crazy directions. If you're defining the angle of your tool by anything to do with the surface normal, then sometimes that toolpath gets just disrupted because the surface normal changes in completely different directions point to point because of just that noisy surface, that badly translated surface. So if that's ever the case, I usually go in here and I create a surface that I know will be clean because it's an original SolidWorks surface. And there you go. So that's overlaid there. What I normally do myself, just as a rule of thumb, is I'll right click on it, and then I'll go and change the appearance of it so that I know that that is my added surface. So I'll just make it yellow. And then I have a surface like that. So like I said, it doesn't really cover the entire surface, but either I can go and add a surface on top of that. Maybe if I drew another line here and then just extruded that edge there, or inside the toolpath itself, if I just give it a tangent lead in, lead out, I can just get it to go from there and just continue a line outwards. It depends on what I'm trying to do with the toolpath. So between those three functions, you have a lot of ability to manipulate and modify and correct some of your surface-based toolpaths, either by doing split line, by doing the untrim, or just creating the surface completely using some of the existing geometry on the part. I think that's it that I can think of for surface-based modifications. There's a lot of crazy stuff up here. Even I don't even usually play with this a lot to know some of the ins and outs of it. But what I would say with this is a good candidate for training with your personalized training, because a lot of this is going to be case by case anyway. What geometry you have, what surfaces you need, what toolpaths you're trying to achieve. So that's a great segue into talking about personal training. So Kevin's going to put my email in the chat section. You can use that email to contact me with the day and time that you'd like to get your own personalized training session. You can use that email to send me your parts, especially for this type of training session. I would say send me the part ahead of time so I can take a look at what you've got and what's the best strategy for tackling that. So if you ever are finding yourself doing 5-axis or anything that's surface-based, send us the part. We can take a look at it and give you a strategy on how to deal with it. That's a great candidate for personalized training. We use GoToMeeting just like this, like we are on now, for those personalized training sessions. It would be over the phone as well, so you can ask your questions live to myself, to Kevin, any of the guys on the team. You can also use that email to contact us for our finder's fee program, where basically if you let us know anyone who is interested in getting new CAM software, SolidCAM, if they don't want to us to contact them, they want to contact us on their free time, give our contact info to them. And in either case, whoever contacts who, you get the finder's fee if they get into a demo, and that is a $100 gift card just for letting us know, putting us in contact with that company. If you let's see, if it goes into sale, then you get 20% of that sale as well. So that could be a chunk of money if it's 5-axis like this, depending on the products that they buy from us. We'll be continuing this every day until the end of the month, 2 p.m. Eastern time. If you have any questions in the meantime, it'll be added to the list of topics we'll be covering until the end of the month. So feel free to just send us those topics. I think that's it. Kevin, you got anything else?
No, that's it.
Okay.
And
you guys
send us your parts, because like we said before, we're getting a little slim on the ideas, but.
Well, there's always something to cover, and there's always a question too. So oftentimes we're going to run out of ideas because we think we've covered everything, but there's definitely something you guys are doing that you have a challenge or you're curious on. This is a great opportunity just for us to be taking time together, everybody, just to figure out how to address that. But definitely, if you have any questions at all, even if it's a very simple question, remember that we cover whatever you need, because the whole point is that you guys learn the software, you enjoy using the software, and you look at us as help. So anything we could do to help you out. You've got the main tech line phone number. You've got our emails. Please, anything you need help with, just contact us. But for today, we'll end it here. You guys stay safe. Keep your family safe. Keep busy. We will talk to you tomorrow.
All right. See you guys.